This differentiation question is taken from a Cape past paper, May-June 2012, paper 2, number 6A. Part 1. Given that y is equal to the root of 4x squared minus 7, show that y dy dx is equal to 4x. And part 2. Hence, that means using the part before, or otherwise, show that y d2y dx2 plus dy dx all squared is equal to 4. So, part 1, we have an explicit function in terms of x. When I say explicit, it means that on the right hand side, we have an expression that's only in terms of one variable, and that is x. What I'm going to do first of all is rewrite the expression in index form. So 4x squared minus 7, the square root is equal to 4x squared minus 7 to the power of 1/2. Now this is a nested function, or what's commonly called a composite function. We have a function here, a quadratic function, nested inside of an index function. So 4x squared minus 7 is one function, and when we raise it to a power, that is another function. To differentiate composite functions, we use the chain rule. So we treat 4x squared minus 7 as one variable, and we differentiate it in the way that we would any polynomial. So this will differentiate as a half into 4x squared minus 7 to the power a half minus 1, which is minus a half. That's how we differentiate a polynomial. So if we treat 4x squared minus 7 as a single variable, it would differentiate in that way. But we have to remember that we have a function nested inside here. So we have to multiply, and this is where we apply the chain rule. We must multiply by the derivative of the term inside the brackets. That's 4x squared minus 7. When we differentiate, we get 8x. So we multiply by 8x. And this is the chain rule. Simplifying now, a half by 8x is 4x by 4x squared minus 7 to the power minus a half. Using the negative index rule, this simplifies to 4x divided by 4x squared minus 7 to the power 1/2. Or if I put this in root form, it's over the root of 4x squared minus 7. Now, I have differentiated y with respect to x. Recall what I'm trying to show. Y dy dx is equal to 4x. So now I have dy dx, so I'm going to multiply it by y. So y dy dx is equal to, recall that y is the root of 4x squared minus 7. Root of 4x squared minus 7, and dy dx, it's right here. 4x divided by the root of 4x squared minus 7. So y times dy dx is equal to root 4x squared minus 7 times 4x over the root of 4x squared minus 7. Now these two terms will cancel, and I will end up with y dy dx being equal to 4x. And that is the solution for part 1. Now we're going to use this to obtain the result that we're trying to show in part 2. That is y d2y dx2 plus dy dx all squared being equal to 4. So I'm going to have to differentiate both sides of this expression with respect to x. Now, that's straightforward on the right hand side because this is a polynomial. This will differentiate as 4. However, it's not so simple on the left hand side because this is not explicitly in terms of x. We also have a term y and dy dx. This is going to have to be differentiated implicitly with respect to x. The important thing to note is that y dy dx is a product. Y multiplied by dy dx. So we will apply the product rule just as we would for a normal product that's explicitly in terms of x. So what we're going to do is differentiate both sides with respect to x, and we are going to obtain, so applying the product rule, I'm going to leave y as is and differentiate dy dx in terms of x. So first I will get y, now this remains as y, dy dx, when I differentiate with respect to x, I'm going to get the second derivative, d2y dx2. d2y dx2. Now, plus, so I'm applying the product rule, dy dx is going to stay as is, and I'm going to differentiate y with respect to x. When I differentiate y with respect to x, I get dy dx. And then I simply write dy dx, that's this dy dx here. And that's equal to, differentiating the right hand side, differential of 4x is 4. And finally, to simplify, y d2y dx2 plus dy dx by dy dx is dy dx all squared, and that is equal to 4.